Hello, BTECH Dt. Today's online lecture topic is freezing, principle, methods, and application. What is freezing? Freezing is conversion of liquid content of food into ice crystals. Basically, it is phase change from liquid to ice. It lowers down the water activity and microbial growth is arrested due to cold shock. Now, what is water activity? Water that is available for microbial growth is basically covers into the water activity. Why? Because there are two types of water, two forms of water in the cell are available. First is bound and second is unbound. Now, what is bound water and what is unbound water in context to the microbial activity? The microbial cell can only transfer nutrients in and waste material out from its own through the cell wall. The materials therefore must be in soluble form to permeate the cell wall. So a portion of total water content present in the food is strongly bound to specific sites and does not act as a solvent. So basically, bound water plus unbound water is equal to total moisture content, and unbound water which is available for microbes metabolic activity is covered under water activity. Now, how water activity can be measured? Water activity is measured through the vapor pressure. The water activity of a food is the ratio between the vapor pressure of the food itself and the vapor pressure of distilled water under identical conditions. Now, what is the vapor pressure? The vapor pressure of a liquid is the equilibrium pressure of a vapor above its liquid, that is, the pressure of the vapor resulting from evaporation of a liquid above a sample of the liquid in a closed container. Now, we can understand this vapor pressure by a simple example. If a bottle is closed and its temperature is raised, the vapor pressure in the head space will increase because of the evaporation of the water. So basically, at room temperature, from the total amount of unbound moisture, some part is vaporized, which creates the pressure in between the food system, in between that specific food system. So now we can understand how lowering the water activity can arrest the microbial growth. Pure water is frozen at 0 degree centigrade, but since fruits and vegetables contain number of dissolved solids like sugars, acids, they freeze at below 0 degree centigrade. Now, why these things, these solids, sugar, acid, they freeze at below 0 degree centigrade, whereas pure water is frozen at 0 degree centigrade? Because when only water is freezed, there is only water molecules which interacts with each other and they make hydrogen bonds with each other and they easily freeze. But when sugar is there or any other solid is there, it interferes with the structure, the chemical structure of the water, and this disturbance in the structure delays the freezing phenomena. Now, process of freezing. During freezing, the commodity cools down below their freezing point but doesn't freeze. This phenomena is called supercooling. Now we can understand this supercooling phenomena by looking at the figure or the graph between time and temperature. Now we can see the graph is coming to B from A. It is moving from A to B, and the C point is the freezing temperature. First, this liquid which has first the liquid comes to the temperature below the freezing point, that is B, and then it increases to C, which is the freezing point of the particular product. Now, this difference is known as supercooling phenomena. Now, we can understand why this sentence is saying during freezing the commodity cools down below their freezing point but doesn't freeze. As we can see in the AB phase of curve. At supercooled storage, nuclei formation or nucleation, which is the first and most important step in the ice crystal formation in the freezing process. Why it is important? The nucleation is very much important in the process of freezing, because when within the structure of water, first ice crystal nuclei is formed. Here we can understand, then first nuclei is formed, then it attracts all the rest of the molecules to attach with that nuclei, and this triggers the ice formation. Now, here the temperature of water will be lower than 0 degree centigrade, but it will remain in liquid form. Remember the supercooling phenomena. At this stage, further lowering of temperature results in the formation of ice crystal. The second step is called crystal growth stage. The release of heat of crystallization further enhances temperature, that we can clearly see in the curve, that during supercooling it goes from A to B. When crystal is formed, the crystal energy of crystallization is released, the heat energy of crystallization is released, and it goes from B to C. The temperature is increased. As we can see, the temperature is on y-axis and time is on x-axis. Since food molecule contains substantial amount of solute, hence a progressive freezing occurs as depicted. Various water molecules gathers around nuclei, and due to subsequent addition, crystal growth occurs. Nucleation may be either due to change in chance orientation of molecule or due to introduction or induction of nuclei from outside. So to accelerate the freezing process, the nucleation can occur naturally, or nuclei from outside can be inducted to increase the rate of freezing. In next step, crystal growth around these nuclei occurs as a result of ice crystal formation. Heat of crystallization is generated, which cause increase in temperature of commodity. So basically this process occurs like from A to B, the supercooling phenomena, then release of crystallization energy, B to C. C point is the freezing point, there freezing occurs, then crystallization occurs at high speed, so lowering of temperature is there. Now when heat of crystallization releases, then temperature increases from D to E. As we can see, whenever heat of crystallization released, there is increase in temperature. From B to C we can see, from D to E we can see, and after crystallization process is over, the lowering of temperature is there. So this is the schematic diagram of freezing process. Now what are the advantages of freezing? There are no nutrient loss, almost no nutrient loss, retain freshness of commodity, retain color and flavor, no microbial contamination is there, no respiration, hence longer shelf life is there. Basically, if we compare with it thermal treatments with other thermal treatments, the retention of nutrients and extension of shelf life is more than thermal treatments. Now effect of freezing or type of freezing. Freezing process can be divided into two categories: slow freezing and quick freezing. Slow freezing when thermal arrest time is more than 30 minutes. What is thermal arrest time? Thermal arrest time is the time from when freezing started and when the crystallization process ends. When thermal arrest time is more than 30 minutes, The process called slow freezing. If the thermal arrest time is less than 30 minutes, it is called as quick freezing. Now, what is better, slow or quick? In slow freezing, less number of nuclei is formed and crystallization around the less number of nuclei is there. And in quick freezing, there are number of nuclei and less ice formation around all the nuclei in comparison to the slow freezing. But slow freezing is detrimental, or the lower type of freezing in context to the quality, and quick freezing is the good process in comparison to the slow freezing. Why? Because slow freezing, the making of less number of nuclei affects the turgidity of cell, and they collapse, and on thawing cannot regain their original shape. What is the turgidity of the cell? The turgidity of the cell is in general terms known as the capacity of a cell to hold its water content. So, capacity of the cell to hold the water content lowers when there are large ice crystals are there. And when thawing, what is thawing? That is increase of temperature, or freezed material is kept at the room temperature to regain its normal shape or normal state or normal phase, that is thawing. No, why it is difficult to regain product's original shape after slow freezing? Because the less number of nuclei attracts more water, and more number of cells are freezed around small nuclei, and during the thawing process, rupture of the cells can be there. Also, crystals forms are larger in size, and it can pierce the cell membrane or puncture it or damage the cell during the natural thawing process. Because when ice crystals will release water, it can have the particular shape that is capable of piercing, and this piercing capacity can damage the cell. Whereas in quick freezing, large number of nuclei are there, and having large number of crystals of smaller size evenly distributed within the cell and in the intercellular space. Since the process is very quick, hence no concentration effect, and commodities retain their original shape, because during thawing, small nuclei releases water, and their small piercing shapes cannot damage the cell in comparison to slow freezing. We can see from this curve the difference between slow freezing and fast freezing, as slow freezing needs more time, as on the x-axis there is time and on the y-axis there is temperature. So, and in fast freezing or quick freezing, it needs less time, and the critical zone is there because this critical zone depicts the shape and size of the ice crystals. Now, freezing methods. Mode of heat transfer in freezing food products is convection. What is convection? Through the water molecules, one molecule to the other. This is the mode of heat transfer into the freezing food products. Now, what are the factors which should be considered while selecting a freezing method? That is product dimension, shape, specific heat, thickness of pieces, freezing rate, packaging, food product components. So these are the factors which should be in the consideration before designing the or before selecting the freezing method. Now, the types of freezing. Air freezing is an oldest method of freezing and utilizes cool air having a temperature of -18 to -40 degrees centigrade as freezing method. Air freezing can be done by tunnel freezing, fluidized bed freezing, air blast freezing. Air blast freezers recirculate air over foods at between -30 and -50 degrees centigrade at a velocity of 1.5 to 6 meter per second. The high air velocity reduces the thickness of boundary air films. Airflow is either parallel or perpendicular to the food and is ducted to pass evenly over all pieces. So basically, the very cool or freezed air -30 to -50 degrees centigrade is blasted upon the food for quick freezing, but this immense amount of freezed air, lower temperature air with this kind of velocity may result in excessive drying. It can be costly. Then it is efficient, more rapid heat transfer, but capital cost can be there. It can result in excessive drying and short freezing time, so less moisture loss can be there. Now, plate freezing. The commodity is placed over a plate and plate is cooled by a refrigerant. So, plate freezing is a slow freezing process. And then liquid immersion freezing. Certain liquids like NO2, liquid nitrogen, liquid ammonia are used as cryogens, and in these liquids the packaged food products are immersed for freezing purpose. Now, cryogenic freezing. In this freezing, the refrigerant absorbs heat from the freezing food. The heat provides the latent heat of vaporization or sublimation of the cryogen, and the cryogen is in intimate contact with the food and rapidly removes heat from all surface to produce high heat transfer coefficient and rapid freezing. So basically, refrigerant is used to absorb the heat, and in phases this heat the product's heat is absorbed, and finally the product is freezed. So this is the very good method. At flavor loss is less, drip loss is less, then oxidative changes are less, improved texture of the product. So cryogenic freezing is the best way to freeze. Now what are the effects of ice formation? First and very much important change is associated with the ice formation, that is volume change. The volume of ice is 9% greater than the pure water when water is transformed into ice at 0 degree centigrade. So we know the freezing expands the food. So for expansion we have to ready to accommodate that expansion. Accordingly we have to design the packaging. Then the moisture content. High moisture content in food produces greater changes in volume, as we know that the volume of ice is 9% greater than pure water. So if moisture content is high, then there will be the greater change, greater increase in the volume. Then cell arrangement in fruits and vegetables. Fruits and vegetables have intercellular air spaces which absorb internally, increases in volume without large changes in their overall sizes. So this is the process where airspace tries to increase, but the ice formation doesn't allow that. Then concentration of solutes. High concentration reduces the freezing point, and foods do not freeze or expand at commercial freezing temperatures. So we have discussed that concentration of solutes disturb the chemical structure of the water, so it reduces the freezing points. Now freezer temperature depends the degree of expansion. Then temperature range, it also dependent on the product as well as the process or technology that is selected. Then crystallized components, ice, fats and solutes contract when they are cooled, and this reduces the volume of food. Then concentration of non-aqueous system. The non-aqueous systems have pretty much higher concentration in the food system. So what is the effect on the concentration of non-aqueous system? Water structure and water solute interaction may be drastically increased. Macromolecules will come together and many detrimental reactions may occur. Because when there is no water available to interact with the non-aqueous system, so it will affect properties like pH, titrable acidity, ionic strength, viscosity, freezing point, etc. So basically, as freezing progresses, concentration of a particular solute increases and eventually reaches or exceeds their respective saturation concentration, crystallization. So basically we know that there are changes in the situation of non-aqueous system or non-aqueous parameters like carbohydrate, protein, fat, they increases in the concentration, and definitely their internal characteristic changes, but they have no or negligible effect on nutrient availability or nutrient concentration or nutrients composition. So basically we can say that freezing preservation is one of the most beneficial preservation method. I think it is clear. You have to prepare handwritten notes from this particular lecture, that is freezing principle, methods and applications.